10x minus 10. At this point, we have to use the zero product principle, which means that we have two possibilities. Either x plus 10 is 0 or x minus 10 is 0. So then from here, how much is x and how much is x? Yes, minus 10 indeed, and 10. So that was a good warm-up. Let's look at another problem. Any questions here? Okay. We selected part C. 4x squared minus 18x equals 70. Okay. Again, for our little notebook, I have two keywords for you. I'm going to ask you throughout the course, what are those keywords? And I'm giving them to you right now. Factor, simplify. These are two keywords. They have to be in the back of your mind every time you look at a math book, you solve a problem, you do homework, you come to class, at all times. Factor, simplify. Okay, so we are given this equation and we are asked to solve it. First, I'm going to simplify it because I can. So these three terms have something in common that I could get rid of, which will not affect the final solutions. No, I will never divide by x. Thank you for saying, or I think I heard it. It's okay if I'm just imagining it. I apologize. We have to write exactly. We have to divide both sides by 2, but this is a very important note. Never divide both sides of an equation by x or expressions having x. Never. Yes, we will be dividing by 2. So the new equation, can anyone dictate the new equation after you divide it by 2 and move 70? (2x squared minus 9x minus) very good, equals? 0. Yes. Remember, if you forget the equal symbol and 0, you're not going to solve. Good. Now, I go back to my strategy. I'm factoring a polynomial. Is it in descending order? Greatest common factor? No. Negative leading coefficient? No. Which of these three strategies will I follow? Number 1, number 2, or number 3? If it's a binomial, I will follow the first one. If it's a trinomial, I'll follow the second one. If it's a polynomial, 4 terms or more, I will follow the last one. So of course, the second one. Perfect. So I will definitely try these first. That's why right? Which is a squared plus 2ab plus b squared, which is a squared minus 2ab plus b squared. But this must be a perfect square. This must be a perfect square. Is this a perfect square? No. Is this a perfect square? No. So these two do not work now. So I can move on. These do not work. I can move on to this. 1 is the leading coefficient. Is 1 the leading coefficient? No. So the third one doesn't work either. So this is my last chance, my last possibility. Okay, ready? Good. So I'm trying to find two numbers whose product is in a moment, and the same numbers whose sum is this. The middle coefficient is always the sum. So this is -9. But the product, because the leading coefficient is not 1, this is the product. -70, that's the product. So let's try to find two numbers whose product is negative 70 and whose sum is negative 9. So let's analyze something first. If the product of the two numbers is negative, am I looking for two positives, two negatives, or one positive and one negative? One of each. Do you all agree? There is no way two negatives will give me a negative or two positives will give me a negative. So I'm looking for a positive and a negative. Perfect. So now the product is 70. Let's say 70 is a big number, but I know in prime numbers is 7 times 2 times 5. So if that's the case, let's use all these factors and come up with two numbers, one negative and one positive, whose sum is negative 9. Say it again. 2 and 7, one is negative, one positive. First of all, the product will not be negative 7 and the sum will not be negative 9. I have to use everything. It cannot be 2 and 7. I have to use everything so that the product is still negative 70.
It's going to be 5 and negative 14.
Exactly. So this will be the negative 14 and this will be the 5. So negative 14 and 5. Perfect.
I must have been looking down, or maybe I spaced out. Let's be honest. How did you get that one more time with negative 14 and 5?
I decomposed 70 in prime numbers. So I have 2, 5, and 7. And by simply looking at this, I realized that if I put these two together into negative 14 and this one alone in 5, the sum will be negative 9. And I had to use all factors. Is that better?
Yeah.
Perfect. Now, the next step is I rewrite the equation. 2x squared cannot be changed, but negative 9x becomes positive 5x minus 14x. So I'm using the numbers we just determined to replace this middle term by 5x minus 14x. I didn't change the problem. I just turned 3 terms into 4 terms, but I didn't change the problem because this is still negative 9x. I copy negative 35 and I copy equal symbol and 0. Now, do not go back and combine because we are going backwards then. Now I'm in this situation. When I have 4 or more terms, I will factor by grouping. And here's what I do. I refuse to look at the last 2 terms. You can say, but what if you have to regroup them? It's possible. So I refuse to look at the last 2 terms before I find out what is common to these 2. What is common to these 2 terms? Perfect. Awesome. So I will factor out x. What is left in parentheses?
2x plus 5.
What should I have coming out from the other 2? And of course the equal symbol and 0. Before I even look, I need to write it because who knows what I come up with? I may make a mistake, a sign mistake, who knows? What do I have to have in parentheses so I can continue? For sure, guaranteed.
2x minus 5.
Say it again.
2x minus 5?
I will not be able to continue if it's 2x minus 5. I will not be able to continue. So this is your hint. If these 2 are not the same, I can't do it. These must be the same. That's why I don't want to look, because who knows, I may come up with 2x minus 5 and make the mistake. Now I look. I know it's there. How do I know it's there? Because I found these numbers. So now I need a sign and I need a factor. If you don't write the sign or you don't write the factor, you're messing up the problem. What is the sign and what is the factor?
So,
Of course. Negative 7. Let's check. We cannot fabricate it. It's there. Negative 7 times 2x, is that negative 14x? Negative 7 times positive 5, is that negative 35? Do you understand why I wrote it first? So that I prevent from writing myself from writing who knows what. Now I know these are two terms. What is the common factor? I want to write it outside right now. Indeed, the common factor that comes out is 2x plus 5. That is what I see in both terms. And now in parentheses, correct. So now we are back to the zero product principle. When the first factor is 0, 2x plus 5 is 0, x equals, I move 5, it becomes negative, and I divide by 2. And in x minus 7 is 0, I move 7, and bless you, and I'm getting the two solutions, negative 5 halves and positive 7. And
for every problem?
no, you can use a different factoring method if you have one.
No, I'm just talking about when you say zero out principle. The zero principle, like I would have just thought that the 2x plus 5, 7x equals 0. And I would just turn my paper in.
2x plus 5 equals 0?
No. When everything
Right here?
0, yeah.
Without this?
Yeah.
But the question is solve for x. You haven't solved for x. You didn't tell me x must be blah for this equation to work. You haven't told me that. You only told me that this product is 0.
Okay.
But the question is, when you're asked to solve the equation, you have to say, for this equation to be a true statement, x must be blah and blah. For anything else, it's a false statement.
Okay.
Better?
Yeah, I didn't know.
I have a question.
Yes, please.
I'm not really understanding why you hid half of the equation when you have to pull out the least common denominator. You had to pull out negative 7 to pull out the least common denominator for these two numbers. So why?
Can you say it again, please?
So when you did the first half of that equation.
You mean here?
Further down.
No, further down. So when we were at x parentheses 2x plus 5 minus 7 parentheses 2x plus 5
Right.
equals 0.
Yes.
You covered half of that, and you said, what do we have to, what does this have to be? Wouldn't you already have to pull out the least common denominator, which is the negative 7? When you did that, and you said, what do you have to pull out?
No. What I said is, I didn't ask what do you have to pull out. I said, what do you have to have remaining from the other two terms? And I was expecting you to say the same thing, because if I don't have the same thing, and then I asked you, okay, now let's look and see what we pull out.
Okay.
Is that better?
Yeah.
So, because if you remember, it was tempting. You looked at the last two terms, you didn't cover them, and you said 2x minus 5. But that's not what I need. I specifically need 2x plus 5. That's why I want to write it before I look.
Yeah.
Because if I don't write it before I look, I may be tempted to write 2x minus 5 and the whole thing collapses.
I was just confused because if I would have looked at the whole thing, I would have seen negative 14x minus 35, and I would have known that I would have had to pull out a negative 7.
Okay.
And then I would have gotten the 2x plus 5.
Okay.
So I was just confused by the way that we did that.
Okay. Well, as long as you know what you're doing, I'm fine. But when I said, what do we put in here? You were tempted to say 2x minus 5. So that's why I refused to look. I refused to look because I may write 2x minus 5. And that will not take me anywhere.
Yeah.
So I copy it first, and then I say, oh, okay, let me see. Oh, it's negative 7. But again, take from my method what works for you. Change it, tune it, fine-tune it the way you feel better, and so on and so forth. I'm fine. So make the necessary adjustments for this. Okay, taking square roots. Yes, please.
Okay, from the beginning, what would you have done? You said divide by 2.
I want to simplify. I don't want to work with 70 when I can work with 35.
Okay, so you just want to simplify off the top.
If I can.
Instead of simplifying.
If I cannot simplify, then I'm stuck with the big numbers. But if I can simplify, I will always simplify. 2, taking square roots. Second method. Okay. So x squared equals 100. We just solved that a minute ago. How many solutions do you expect? Right, because it's quadratic. So this is a perfect setup for taking square roots. However, this is the intermediate step that is correct, but we don't write it. The left-hand side is the absolute value of x. It's not x when you take the square root of x squared, because we don't know what x is. It could be positive or negative. The right-hand side is very clear. There is no discussion there. What is the square root of 100? Good. And now this is what I have to solve. And I'm asking you, what should I have in here such that the absolute value of this number is 10? Awesome. Yeah. However, we like to omit this step. The reason why I present it is because I don't want you to think that the square root of 100 is 10 or negative 10, because it's not. The positive and negative come from this symbol, not from the right-hand side. That's why I wanted you to make sure. I wanted to make sure that you understand that. So, when is this useful? Really not specifically for this, which we just solved a minute ago by factoring, but for this. This is a typical situation in which we take square roots from both sides. I'm not going to square this, get 3 terms, right, and subtract 16, set it equal to 0, and do something else. No. Because this is typical for taking square roots. Something with x and it's squared, and the number on the other side. That number can be positive, 0, or negative, but alone, just one number, and nothing else. So now I'll take the square root. The left-hand side should be the absolute value, but I'm going to write 2x plus 1. And what should the right-hand side be?
Plus or minus 16.
Plus or minus?
4, sorry.
No problem. If you forget the plus or minus, you only get one solution. So the plus or minus is this and this from here. I subtract 1, and I divide by 2. I have to separate the variable, the solutions. Negative 1 minus 4 is negative 5 over 2. And negative 1 plus 4 is 3 over 2. Very useful method. Very useful method. Any questions? Any questions? This is the method that, as I said, is useful, but not here, really, but we learn it now. So I'm making up an equation, and this is this quadratic?
Yes.
Perfect. And assuming I only have x squared plus 6x, I know I look silly, but I'm hoping that if I look silly, you remember this. That's all. It's a trade-off. I want to use these 2 terms plus another term that you will come up with for me so that I can have a perfect square. Of course, it's one or the other, right? Since this is positive, then I'm looking at this. So what should this be using the terms that I already have and I cannot change, x squared plus 6x? What do you think this should be so that I can write it like that?
9.
Awesome. And if I do add 9 to one side of an equation, what do I have to do to the other side? Good. I'll explain the method in a second and how your colleague got 9. But can you please tell me what will this be?
X plus 3.
Awesome. Awesome. So let's talk about the method now. Steps. 1, 2, 3, 4. So the method of complete the square has 4 steps. Step number 1. Identify the middle coefficient. Remember, everything has to be in descending order. There is no discussion there. We have the strategy. We can't ever forget that. This is the top priority. So when I say the middle coefficient, obviously I'm talking about the coefficient of x. Okay, what is it in our problem?
6.
Perfect. In step 2, divide it by 2. Why do I divide it by 2? Because of this. That's why I divided by 2. To find out what this should be. And then square it. That's why I divide by 2. So 6 divided by 2 is? In step 3, square 3. Please square 3 for us. Add 9 to both sides. That's how we came up with this. So then coming back, I'm going to write the equation one more time, and I'm going to add 9 to both sides. So x squared plus 6x plus 9 equals 8 plus 9. Please remember, it must be added to both sides. Okay. You already told me this, but please, can somebody else tell me what this equals to? Yes, thank you. See, that's why I tortured you with this from day one, because this is going to be forever, all the time, coming up. And the right-hand side is? Right. What did I say a few minutes ago when we started those 4 methods? What did I say about complete the square? Completing the square alone doesn't do the job. Look, I'm here. I haven't solved. But after complete the square, I come back to this method. I have no choice. So I take the square root from both sides. How many solutions do we expect? Perfect. X plus 3 equals, please don't forget what? Thank you. And then I subtract 3. And that's the method of completing the square. Useful, but not for quadratic equations. If the problem is asking you to complete the square, you cannot. You can check with quadratic formula. And this is the last step here. So number 4, quadratic formula. Please give me any equation you want. Any quadratic, I meant to say, sorry. You should have given a logarithmic equation or something. Make one up. 3x squared minus,
8x.
you said 8?
8x,
Very good.
plus 5.
Perfect. The quadratic formula, oops, sorry, requires the equation to be set equal to 0. I mean, the polynomial set equal to 0. I'm going to erase this in a minute. And then the quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. Good. So then I identify the coefficients correctly, and then I just plug them in. I have to be very careful how I plug them in. So then x equals negative b.
It's going to be a positive.
Awesome. Very good. Plus or minus the square root of.
Negative 8.
No, not possible. Sorry. I should have let you finish. You said negative 8.
Yeah, square.
Right, how much is that?
64.
Awesome, yes, sorry, I take it back. My apologies. I thought, because I was going to say this number can never be negative, but you already had the right answer. I apologize. Minus 4 times A times C divided by 2A, which is 6. Okay? Good? Say it again. Very good, yeah. Excellent. Yes. So 12 times 5 is 60. 64 minus 60 is 4. The square root of 4 is 2. So there are two options, and we have to separate them. X equals 10 over 6. And of course, I'll simplify, 5/3. And 8 minus 2, 6 over 6, which is 1. Now you understand why I have to have the solutions, right?
Yeah.
Any questions for me?
So which one did you?
I'm sorry?
I must have been looking down at my paper.
So 4 times 3 is 12, 12 times 5 is 60, 64 minus 60 is 4, the square root of 4 is 2.
Oh, okay.
All this is 2. 8 plus 2 is 10, 10 over 6 is 5/3. And 8 minus 2 is 6, 6 over 6 is 1.
Okay.
I would like us to choose a problem from here because I want to illustrate the power of factoring. Not necessarily this situation in which it's a little bit more complicated, but how important factoring is. So let's say we're going to look at problem 4. Because I would like you to work on these problems and check the answers between now and Tuesday. So let me illustrate with one of them. So 4, 3x plus 1 cubed times 3, 2x minus 5 to the third plus 3x plus 1 to the fourth times 3, 2x minus 5 squared and times 2. So this is the supplement called simplification by factoring.
You want bad.
Simplification by factoring. And it has a lot of explanation. If you can read it, that's great. If you cannot read it, that's fine. That's good enough. We're going to do this in class together right now. I selected this problem. If we have time, we can do another. Okay? So it's on page 6 of simplification by factoring supplement. We all have it? Yes? Okay, perfect. So first of all, I'm going to ask you how many terms we see here. How many? Exactly. This is a product, and we said that it's a product, which means one term. I encountered the positive sign, and this is the second term. So please make sure you understand the difference between terms and factors. Perfect. I will have to rearrange this a little bit because it's kind of spread all over the place. I will multiply 4 by 3. I'm allowed to do that. So it's 12, 3x plus 1 cubed, 2x minus 5 cubed. I'm using the associative and the commutative property of multiplication, plus 3 times 2 is 6, 3x plus 1 to the fourth, and 2x minus 5 squared. Do we all agree so far? I didn't do anything. I just condensed those two
I
terms.
don't think that 4 is there. I think that's problem number.
For that.
Oh, okay.
Problem 4 starts.
Always check. Always check. I may copy something else. It's better to, stop me and say, look again. I'll look again. Always do that, please. Even if there is no mistake, if you think that there is something, you may be right and I may be wrong. Okay, so now I'm looking at these two terms and yes, questions?
Oh, I see, no, I see what you did, I'm sorry.
No problem, no problem. Any question, please? So I see that they have in common a 6, because I'm looking at 12 and 6. What else do they have in common?
2x minus 5.
Yes, but they also have 3x plus 1. Now, this is power 3 and this is power 4. Which one will I keep? I cannot keep 4. If you have 3 apples and I have 4 apples, we don't have 4 apples in common. We have 3 apples in common. So I have to choose the smallest of the 2 exponents, correct? Everyone? Okay. Then 2x minus 5 to which power? Exactly, the smallest of the 2. And now please tell me what is left from the first term. From 12, I took out a 6. So what is left? A 2. 6 times 2 is 12. 3x plus 1 to the third and 3x plus 1 to the third. Anything left?
Nope.
No. From 2x minus 5 to the third, I took out 2 of those. What is left? One of them, 2x minus 5. Plus, I mean right here. 6, from 6 I took 6 out. Is there anything left? No. From 3x plus 1 to the 4th power, I took 3 of those out. Is there anyone left? Yes. And from 2x minus 5 squared, I took all of them out. Is there anything left? Nope. So this is 6, 3x plus 1 cubed, 2x minus 5 squared, and now I distribute 4x minus 10 plus 3x plus 1. 6, 3x plus 1 cubed, 2x minus 5 squared. Can anyone give us the simplified form in parentheses?
7x minus 9.
That's it. And this is it. Any questions? Any questions? You're welcome. Thanks. Open notes, open book, but not your colleagues.
You said it equal to 0. So
This is not an equation. We are only asked to simplify by factoring. Very good question, actually.
can you do it then?
I'm sorry?
You can't solve it, right?
Yes, I can. If it's an equation, then I would have x equals negative 1/3 3 times. I would have 5/2 twice, and I would have x equals 9/7. If it were an equation, yes. Yes. Very good question. Oh, thank you. Any questions other than just that? Thank you.
Are you collecting this?
Yes. Thank you.